Good afternoon, Sur. Today we will be discussing about concept statistics, which is hypothesis for variance and standard deviations. And before we start, I will introduce our member briefly. So here is Amarisa Praba, which is me, and then I have my member here, Muhammad Gazian Hidami, Stanislaus Kianu Sanjaya, Kevin Pradipta, Bilal Chan, and Revanza Reinhardt. So now let's start with the basic. What is hypothesis testing? Hypothesis testing is statistical decision-making process, which is help us make inferences or conclusion about populations using information from a sample. Which parameters we usually tested are includes mean, proportions, variance, or standard deviation, which we will talk later. So why do we care about testing variance and standard deviations? So first thing first, variance and standard deviations indicate consistency. If the standard of deviation is small, it means the data points are close to the mean or leads to more consistency. And so if it's large, it indicates more spread or more variability in the results. Second, these tests help us to reduce the possibility of risks, and it's also useful in quality control, especially in the real world problem. And we will typically use this test when we want to compare the consistency between two different groups, or we want to check if the observed variability exceeds or below the acceptable limit.
So now we will talk about how to find critical values for chi-square test. So here are steps on finding critical values for the chi-square test. First one, we need to specify the level of significance alpha and determine the degrees of freedom, which can be found by subtracting n by 1. And then the third step is the critical values for the chi-square distribution are found in table 6 of appendix B. To find the critical values for A, for right-tailed test, use the value that corresponds to degrees of freedom and alpha. And left-tailed test, use the value that corresponds to degrees of freedom and 1 minus alpha. And for two-tailed test, use the values that corresponds to degrees of freedom and half of alpha, and also degrees of freedom and 1 minus half of alpha. This is how to find critical values for the chi-square test. For the right tilt, here we can see that the nu is bigger than the value. And for left tilt, here is nu is smaller than the value. And two tilt is the nu is not equal to the value.
Okay, so let's go on to the examples. So the question is that we need to find the critical chi-squared value for a left-tailed test when the number of samples is 11 and the alpha level of significance is 0.01. So the solution is quite simple. So first we need to determine the degrees of freedom, which is just n minus 1, 11 minus 1, which is 10. That's the degree of freedom. And now we just need to find the area to the right of the critical value, which is just 1 minus alpha, or 0.099. And as you can see from table 6, the critical value for chi-squared null is 2.558. Let's move on to another example. This time we need to find the critical values for 95% confidence interval when the sample size is 25. Now, again, with the degrees of freedom, it's just n minus 1, so 25 minus 1, that would be 24. Now we need to find the area to the right of the critical value, which is 1 minus alpha, 1 minus 0.95, which leaves us with 0.05. And we know that C is 0.95 and n is 25. So from the table, we can deduce that the critical value is chi-squared left is 12.401, while for the right critical value, it would be 39.364.
Now here's another example. So the question is, find the critical values for n equals 15 and the confidence interval is 99%. The degrees of freedom is n minus 1, 15 minus 1, which is we get from here. And then the area to the right of the critical value is 1 minus alpha, 1 minus 0.99, which is 0.01. We know that the confidence interval is 0.99 and n equals 15. So from table 6, you can see the critical value for chi left squared is 12.401 and chi square right is 4.075. Objective 2 of 2, how to use chi-square test to test variance or standard deviation. The chi-square test is a statistical test for population variance or standard deviation. Can only be used when the population is normal. The test is standard deviation squared or S squared. The standard test statistic is chi squared equals n minus 1 times chi squared divided by standard deviation, follows a chi-square distribution with degrees of freedom, which is n minus 1.
Next is using X-square test for a variance or standard deviation. In words, the first step is verify that sample is random and the population is normally distributed. Next one is state the claim mathematically and verbally, identify the null and alternative hypothesis. The next step is specify the level of significance. Next one, then determine the degree of freedom, and then determine any critical values. And for the symbol, the first step is none. The second one is state H0 and HA. The third one is identify alpha. The fourth one is n minus 1. The fifth one is use table 6 in appendix B. The sixth step in words is determine any rejection regions, find the standardized statistic and sketch the sampling distribution. The eighth one is make a decision to reject or fail the null hypothesis. Then last one is interpret the decision in the context of the original claim. In symbol, the sixth one is none. The seventh one is x squared equals to n minus 1 s squared. The eighth one is if x squared is in the rejection region, reject HO, otherwise fail to reject HO. The ninth one is none.
An example of a hypothesis test for the population variance. A dairy processing company claims that the variance of the amount of fat in the whole milk processed by the company is no more than 0.25%. You suspect this is wrong and find that a random sample of 41 milk containers has a variance of 0.27 and alpha 0.05. Is there enough evidence to reject the company's claim? Assume the population is normally distributed. You can see the calculations involved, and at the end result, we failed to reject H0. At the 5% level of significance, there is not enough evidence to reject the company's claim that the variance of the amount of fat in the whole milk is no more than 0.25. Another example, a company claims that the standard deviation of the length of time it takes an incoming telephone call to be transferred to the correct office is less than 1.4 minutes. A random sample of 25 incoming calls has a standard deviation of 1.1 minutes and an alpha of 0.10. Is there enough evidence to support the company's claim, assuming the population is normally distributed? As you can see the calculations, we have decided to reject H0. At the 10% level of significance, there's enough evidence to support the claim that the standard deviation for length of time it takes for an incoming telephone call to be transferred is 1.4 minutes.
Now here is the summary. So the hypothesis testing for variance and standard deviation is used to test population variance or standard deviation differs claimed value based on chi-squared distribution. Chi-squared equals n minus 1 s squared divided by standard deviation. Assume normally distributed data. And the steps are set H0 and HA, and then choose alpha significance level, and then find critical value chi-squared table, calculate chi-squared, and compare reject or fail H0. And here are the references from where we get it. And thank you, Mr., for listening to our presentation, and that's all.